Okay, question number 19 on the 2009 January Math A Regents exam. Question says, which of the following is false? And it even it doesn't underline, it italicizes the word false because we are looking for the one that is not true. And then it gives us 4 choices, all very confusing sounding at first, but if we know our definitions, we'll be all right. Number 1 says all parallelograms are quadrilaterals. Number 2 says all rectangles are parallelograms. Number 3 says all squares are rhombuses, or rhombi, as I've sometimes heard them referred to. Number 4 says all rectangles are squares. Okay, now it's really, really important that you know the definitions of these words. If you don't, go and get out the math book, get out your notes, and learn these definitions, because these kind of questions are impossible to answer if you don't know the definitions. I mean, you could guess, but you don't actually know that you're right or wrong unless you know the definitions. Okay, so let's go. First one says all parallelograms are quadrilaterals. Okay, that means every single parallelogram in existence is a quadrilateral. Okay, a parallelogram is a 4-sided figure whose sides are parallel, whose opposite sides are parallel. So those 2 sides are parallel, these 2 sides are parallel. That's a parallelogram. And a quadrilateral, that word there, quad, okay, quadrilateral is any 4-sided figure. So since parallelogram has 4 sides, it has to be a quadrilateral. So number 1 is true. It has to be true. Number 2 says all rectangles are parallelograms. Well, all rectangles have 4 sides. The only qualification you need to be a rectangle is to have 4 right angles. And whenever you have 4 right angles, the opposite sides are parallel, just because that's a law of geometry. That's one of the assumptions. So 4 sides, opposite sides are parallel. Every single rectangle is therefore a parallelogram. So that is also true. Number 3 says all squares are rhombuses, or rhombi, as I've sometimes heard them referred to. This is also true. A square is a figure where all 4 sides are equal. And we also have 4 right angles. But all we really care about here is that the 4 sides are equal. A rhombus is any 4-sided figure where all 4 sides are equal. So you can take a square and squish it like this, kind of like a diamond, and so long as these guys are all equal, everything I'm drawing here is a rhombus. O-M-B-U-S, rhombus. Okay, so that's a rhombus, and that's a rhombus, and that's also a square. So yes, every single square, because squares have 4 sides that are the same, is also a rhombus, because all you need to be a rhombus is to have 4 sides the same. Well, that leads us to number 4, which must be the odd one out. Number 4 must be false by process of elimination, but let's actually go through it to make sure that it is false. This says all rectangles are squares. Now, a rectangle, again, all you need to be a rectangle, oops, let's get an actual square here. Okay, all you need to be a rectangle is to have 4 right angles, right? That's all you need to be a rectangle. So this is saying that every single rectangle that exists, including the one I just drew, including this one, is a square. But remember, there are 2 qualifications for being a square. To be a square, you have not only to have 4 right angles, but all of the sides have to be equal. Well, in this picture I just drew, these 2 sides are equal, and these 2 sides are equal. They're congruent, but there's no way that all 4 of these sides are the same. In this picture, every one is the same one. So I have just given a counter example here. A counter example. Counter. Oh dear, that's very ugly. Counter example. Okay, so this is a counterexample that shows that statement number 4 is false. All right, let's go on to the next problem. Next problem says the graphs of the equation x squared plus y squared equals 4 and y equals x are drawn on the same set of axes. What is the total number of points of intersection? Okay, now this is actually a really easy question to answer if you know that x squared plus y squared equals 4 is the equation of a circle centered at the origin with radius 2. Because remember, the equation for a circle is x squared plus y squared equals radius squared. That's the equation of a circle. So this is centered at the origin, and the radius is 2, 1, 2. So that means we're going to have a circle that looks kind of like this. Right? And that is x squared plus y squared equals 4. Plus y squared equals 4. Okay, that's that graph there. And then the line y equals x, that should be very easy to graph. That's just a diagonal line with slope 1 that goes through the origin like this. Okay, that's y equals x. And the points of intersection, well, there's one here and there's one here. The problem doesn't ask for what the points of intersection are. It only wants to know what is the total number of points, and the total number of points is 2. If you really wanted to do this without graph paper, you could just substitute. You'd write x squared plus y squared equals 4. We know that x equals y, so therefore we could just take, oh, I don't know, this x here and put y in its place and have y squared plus y squared equals 4. That's 2y squared equals 4. We divide by both sides and get y squared equals 2, which has two solutions, plus minus the square root of 2 equals y. So the two solutions here comes from the plus minus in front of the square root of 2. And that would actually be the coordinates, plus minus square root of 2. Those are the y coordinates. As well as the x coordinates, because x equals y. X equals y. All right, let's do one more. Number 21 says, express as a single fraction 3 over 4x minus 2 over 5x is equal to. That's really not a very good sentence there. Express as a single fraction 3 over 4x minus 5, or I'm sorry, minus 2 over 5x is equal to. Yeah, it's really not a very good sentence. A semicolon would work? I don't know. I'm not a grammar expert. Let's just get down to the problem. So what we want here is a common denominator. We want to have a common denominator, and if we look, we have 4x and 5x. X's are the same, so that's all good. But the numbers here, 4 and 5, are different. So what we want to do is have a common denominator. 4 times 5, that's 20. So we'll have 20x as our common denominator. That means we will take 3 over 4x and we will multiply it by 5 over 5, which is the same as multiplying by 1, and that doesn't change anything. And we will subtract from that 2 over 5x, and we will multiply 2 over 5x by 4 over 4. Again, the goal is to get the denominators to be the same. So this will give us 3 times 5 is 15, and 2 times 4 is 8, so 15 minus 8, and that is all over 20x. All right, 15 minus 8, that is going to be 7 over 20x. We can't reduce this any further because 7 and 20 don't have any common factors, so that becomes our answer. How about that? All right, we'll see you in the next problem.